So welcome to the presentation of Lab 7. So I'm going to talk about the memory unit for this lab and how to create the memory for 4 inputs here with 5-bit address and 32 bits of data input. So first you're going to create a memory unit using the new source button here. Then when you go to the new source, select IP core generator and architecture wizard, give it a name with your choice. Then go to the next button and select distributed memory generator. Click next, and you can finish by clicking it. So I have already created, so I'm not gonna go over to that again. I'm not gonna create it again. So remember, it should be the core IP core generator, and after that you'll get this one. You'll get the wizard, or you'll get another window for distributed memory generator. Okay. So how does it look? So let's go ahead and try to understand. So here is the distributed memory generator window, and you have to assign your width and depth value in here. For this lab, we're gonna choose 32 bits for width and depth, and your memory type, as we're talking about single port RAM, so you're gonna choose this one, and then you're gonna click next, and your file should get the input options. They should be remain as non-registered, and then you can click next. For the next option, you don't need to do anything right now. Just leave it as it is, and then click generate button. So I've already created this one, so go ahead and click this generate button, and you'll see a memory will be generated. You'll see the generation of a memory, and this memory will it'll take some time to be generated, so you need to wait a little bit. So let's go on. So let's go on to the schematics. I've already created a schematic, and I've already put the symbols in here. You can find the symbols from your symbol wizard in here, and you need to type your memory name. For example, I have given the name as mem_exp7. So as you can see, you can find out the option for symbols, and then you can put it in here. So after putting it, you can have those input and output ports. For instance, for your input ports, you need to assign the address and then the data input, and for the enable button, you need to put this one, which is going to enable your read and write option, and this is the clock signal for your input ports. So maybe sometime you cannot understand what kind of port this memory unit has. Then you can check the data sheet from the wizard menu, and then you can check all of the input ports. So after assigning these 4 input and output ports, as you can see in here, you need to go ahead and put the design option in here. So as you can see, I put the design option, so you can simulate the behavioral model and see what's going on with the timing diagram. And also you can check it with the VHDL code, VHDL Testbench code. So I'm gonna go ahead with the VHDL test code. And for that, you know how to generate that from the previous labs. So I'm not gonna go over with that one. I have already created the VHDL code file, and here you can see the code in here, the VHDL code. And let's get started with this one. This one has the previous previous ports. We have already talked about these things, And also we have the address input, data input, and the clock signals, and the enable button, and also the data output. So what you have to do, you don't need to change this one. It should be as it is. And then you have to go ahead for the test bench part. So in this part, you need either you can put a different process for your clock signals and for your data inputs. So in here, I have declared a clock signal with this process. And in this process, I just put the time period as 50 nanoseconds. If you want to put like clock signals with the not option, like the inverter option, you can do that, and then you can have the clock period. What will be the clock period for your clock signal? And then you have to have another process which should have this kind of value. I mean, for this lab, you're going to check different kind of inputs for your address and the data input. And with that, you can check the enable button as well. And also you can have you can have 4 or 5 different types of input. So in here, you need to 4 groups of value, and you need to check 4 groups of value, and then you need to examine, or you can test it with your timing diagram. So I have several inputs in here for the data input, and you can have, I mean, these outputs, these inputs are basically in binary format. So I just put it in the decimal format, and then this function is going to convert it into unsigned. It's going to convert it into binary value for the timing diagram. And let's see what's going on in the timing diagram. And I've already done the simulation part for timing diagram. Let's go ahead with the timing diagram for this VHDL test bench. So here we have the timing diagram from the VHDL test bench. As you can see, I have several inputs for the data. I mean, data input has several numbers, binary numbers, and then I have the address to store them, and I have the data output for the output port. And also I can use the clock signal and the enable port for reading and writing the values in the address. So in the specific address, for example, for first one, I have chosen 26, and the data is 250. So they're going to, it has the clock signal at first point, it's 0, but we have the enable as 1. So it's going to store the value of 250 in this address. So, and I have the data output. So in that case, when it's going to have the clock signal as 0, there's nothing to be done, or nothing to be, I mean, it'll not show anything, because since it's the clock signal is 0. And when the clock signal is going to 1, and then these 250 will be stored in these address, and that's why it's showing the output, showing the data output as 250. And then again, and on that case, all this time the enable was 1, and still now it's 1, and again the clock signal is going to be 0. This time we have given the address is at 6, we have given the address as 6, and the data input is 13. In that case, since the clock signal is not 1, so it's not showing anything, it's not going to store anything. But when it's having 1, then the address will store, the device will store 13 in the address. That's why it's showing the output as 13. Then we have the enable. After that, the enable has gone to 0. And in that case, we have specified the address as 3. In that case, the device is in reading mode. So far, it was in writing mode. I mean, it was storing values, but now since the enable port is 0 and there is nothing to be stored, rather it's going to read the value. In that case, we have the address as 3, but in the previous cases, we didn't use 3 for the address and to store any value in that address. That's why you can see even if the clock signal goes to 1, there is nothing to be shown. Then there's nothing showing on the data output because there's no value stored in this address. That's why it's showing 0. So after that, since the enable is 0 as you go on, and then you put 6 in your address, and in that case, at first it's going to show you since it's in a reading mode, it's going to show you the value of 13. Why is that? Because in the previous cases, in the previous clock stream, we have stored the value 13 in 6. That's why it's showing 13. And I mean, that's why it's in the reading mode. That's why it's showing the 13, since we have stored 13 in the address, in this address. And also you can see that the 250 the data input has 250, right? But it's not showing in here. Why is that? Because the enable is off. That means it's on 0. That's why it's not storing any value in 6. Okay, that's why we are having it's just showing the previous value that has been stored in the address 6. Now, as we move on, it's going to be same because you have your enable function is not on, and then you change the value for the address. When you change the value for the address, which is 26, this 26 is from the previous one, right? I mean, we used it in this case, right? And we stored a value of 250 in this address. That's why it's showing 215 here. Now, when the enable becomes 1, as you can see in here, it looks what? In first case, it's showing the same value because we stored 250 and 26. But when the clock signal becomes 1, it's going to store 250 again in this address. That's why it's showing 250 again, right? So, and then again, you have the enable as 1. Now you chose 6, and then you store the value of 13. That's why it's showing 13. So, and the other, and also if you check with Z3, again, it's going to show you 0 because there's nothing stored. There's nothing to show in this address because no value has been stored in this specific address. That's how you can analyze and explain, I mean, the whole timing diagram. And you have to show this kind of values. So remember, for your report and your experiment report, you need to show these types of values and have these clock and enable ports to demonstrate your data output. Okay, that's it for this lab. Thank you, guys.